Welcome to Prince Maths Clinic, the e-learning solution at your pace and time. It's a beautiful day and welcome once again to Prince Maths Clinic. Today we shall be looking at some beautiful questions that are based on the laws of logarithm that we have examined so far. If you have missed that class, please kindly look in the description of this video to find the part 1 and the part 2 of the laws of logarithm, as well as a detailed explanation of what logarithm entails. Now, if you have not subscribed to this channel, kindly do so by clicking on the subscribe button, and you can also do well to share this video to your friends and loved ones so that we can all get better in terms of mathematics. Having said that, let's go right into the solution. So the first question says we should evaluate without using tables. That means when we say to evaluate without using tables, that means we don't want you to use the calculator or the four-figure table. So this, all right, now the question, log 144 base 10 minus log 90 base 10 plus log 0.0625. Let me take this part again. 0.0625 base 10. All right. So the first thing to do, applying the laws of logarithm. We remember that we said that when you have two logs, as this log a base b plus log c base b, as long as the bases are the same, that we can multiply these two logs together, right? And it becomes what? Log ac base b. And we also agreed that when we have log a base b minus log c base b, you becomes division, right? This becomes log b, which is c over a. So we are going to combine the laws now to solve this. In order to solve this, we need to first of all make this look like a fraction, and to do that we know that we have 2 points after the decimal, so this becomes log 144 over 100, then minus, this is normal, log 90 base 10, then this is plus log, this is 625, then we have 4 digits after the point, so that is that. Now that we have done this, we have said that subtraction means division and plus means plus means multiplication. So we are going to do it like this. We are going to bring in the rules to play now. So this becomes 144 over 100. This is division, right? Divided by 90 over 1. Then this is multiplication, 625 over 10,000. Then once division turns to multiplication, what is in the denominator will go up, what is in the numerator will come down. So therefore, this would now become times 1 over 90. When you now divide this or multiply all you have here, this is what you are going to have. You are going to have 1 over 1,000. That's what you are going to obtain. And we know that 1,000 is 3 zeros, so you can write it like this: 10 to the power of 3 at the denominator, which is the same thing. Instead of writing 1 over this, you can write it like this. This can be expressed because of this division. This is this 10, then this division is this power, then the power here 3. Then apply the law of logarithm that says once a log, if you have log n base x base b, x will multiply this, so the power will now multiply this, so this now become x log n base b. So using that law here, minus 3 will multiply this, so this become minus 3 log 10 base 10. And when a log and a base are the same, it turns to 1, because log 10 will cancel this, log 10 will cancel this base of 10. So therefore, minus 3 times 1 becomes minus 3. So this is the solution to this first question. Let's look at the second question. What we need to do is to bring out this, since log 2 is common to all, then you interpret, this becomes division, this becomes multiplication. This becomes 27 over 4 divided by 9 over 8. Then this is times 1 over 24. Therefore, when division turns to multiplication, it becomes 27 over 4 times, the denominator will go up to become numerator, numerator become denominator. This becomes times 8 over 9 times 1 over 24. Now let's divide systematically. 9 can go here 1 time, 9 in 9 1, 9 in 27 is 3, 3 here 1, 3 can go in 24 8 times, 8 in 8 is 1, then 8 cancels 8 here 1. So I have 1 over 4 left. And 4 can be expressed as 2 raised to power 2. Two raised to power 2 same as 4. And in fraction like this, it can be expressed as log this base of 2 carrying this power will be expressed as negative 2 because of this division. Then the base is 2. Then you know that when a log is carrying a power, the power multiplies the log. Then this becomes, this power multiplies this, so this becomes minus 2 log 2 base 2. And when a log and a base are the same, they cancel out. So this cancels this. So minus 2 times 1 becomes minus 2. So that is the solution to this second question. Now let's look at the third question. The number 3 question says that log of 49 to the power of a base 7 minus log of 0.01 base 10. Good. Now you notice that the bases are not the same, but don't let that bother you, because this question is about to crumble like a pack of cards. 49 can be expressed as this. 7 to the power of 2 gives us 49. Then 49 is carrying a power of a, you put that a. Then it has a base of 7, you put the 7 at the base. Minus. Then this 0.01 can be expressed as 1 over 100. It is 100 because you have 2 digits after the point. That's why you put 2 zeros. Then this one is this one at the numerator there. So base of 10, you put the base of 10. Now when in indices, when a power is multiplying a power, you use the powers to multiply themselves. So this becomes log of 7 multiplied by 2a. Then the base is still base 7. Then minus. This can be expressed as 1 over 10 to the power of 2, because if I square 10, I get 100. Then to write the whole of this, since this is 1 over, I've said time and again that once you have something like this, it becomes, if you have 1 over 10, is the same thing as 10 to the power of minus 1, because the power of 10 here is 1. Now that you have the power of 10 to be 2, this becomes 10 to the power of negative 2. So instead of writing this, I want to put it in this form here. Good. So this becomes 10 to the power of negative 2. Therefore, you can see clearly that the log is carrying a power here. The log is carrying a power. So the power multiplies each of these logs. So this will now become 2a log 7 base 7 minus, then this is minus 2 log 10 base 10. Here the log and the base are the same, so they will cancel out to give us 1. Then here minus and minus will turn to plus. Then the log and the base are the same, cancels to give us 1. So what do we have here? 2a minus and minus turns to plus, then 2 times 1 is 2. So we have successfully, right, solved this question. Now let's look at the fourth question. We are given that log 4 base 2 plus log 2 base 4 minus log 5 base 25. Looking at this question, a critical observation shows that they have different bases. So this question can be rewritten in another form that will still mean this. So watch what I'm going to do. I will leave this as, okay, let me make this 4 2 to the power of 2, having a base of 2, then plus, I want to leave this as it is here, base of 4, but I'm going to call this 4 to the power of half. I know when anything is carrying the power of half, it means square root. So square root of 4 is still 2. Good. Then minus, then I will leave the base here still at 25, right? So if I say 25 to the power of half again, square root of 25 is 5. So the two statements are the same. Then I can now use the rule that says that when a log carries a power, the power multiplies the log. So this 2 will come here. So this becomes 2 log 2 base 2. This half will come here plus 1 over 2 log 4 base 4. Then this other half will come here minus 1 over 2 log 25 base of 25. The log and the base are the same, cancel out, turns to 1, turns to 1, turns to 1. So here half 2 times 1 is 2, plus half times 1 is half, then half times 1 again is half. So here half minus half is 0 plus 2, which is 2. That is the solution to this particular question. Now let's take a look at the last question for today's class, which is this. We have to simplify this, which is 2 log 2 over 5 minus log 72 over 125 plus log 9. Let me state categorically here that once you see a log like this that does not contain any base, the base is in base 10. So we have to reverse this. This is 2 multiplying the log, so this can be written as log of 2 over 5, then all to the power of this 2, because it was from here it multiplied the log, minus log of 72, right, over 125 plus log 9. 2 squared means 2 times 2, so that is 4. 5 squared is 25, minus log of 72 over 125 plus log 9 over 1. Now the moment of truth. Since I've said logs are having the same base, so what do? Or let me write this like this: log of 9 over 1. Now, what do we do from here? This becomes base 10. So this is 4 over 25. You know this is division, right? So put it like this, divided by 72 over 125. Then this is multiplication, 9 over 1. And once division turns to multiplication, what is denominator becomes numerator, numerator becomes denominator. So this becomes times 125 over 72. So the journey begins to simplify. 25 can go in 125 5 times. Nine can go in 72 8 times. And 4 can go in 8 2 times. So we are left with 5 over 2. So everything here simplifies to 5 over 2. Now, there's no crime in leaving your answer here. If you can leave it like this, better. But we can still simplify this further, right? This 5 over 2, going by the laws of logarithm, can become log 5 base 10 minus log of what? 2 base of what? 10. That's in interpretation. Log of 5 base 10 can be written like this: log 10 divided by 2 is still 5. 10 divided by 2 is still 5. Then base of 10. Then minus log of what? 2 base of what? 10. Good. Then, using the laws of logarithm, this divide becomes what? Subtraction, right? So this becomes log of what? 10 base 10 minus log what? 2 base of 10. Then this is another minus log 2 base of 10. Now a log and a base are the same, it turns to 1. Minus, then you have log 2 base 10 and log 2 base 10. So this becomes 2 log 2 base of what? 10. Because it's like saying apple, log 2 base 10 is like x, or 1 apple, 1 apple. So 2 apples that are subtracted becomes 2 apples, right? Good. So this is the solution to this question. But don't forget, like I said, you can leave the answer in log of what? 10, 5 over 2. There's no crime with this. This and this have the same implication. Having done all of this, I want to believe that by now you should be able to simplify any given logarithm question, right, using the rules of logarithm. And to confirm that fact, I leave you with this question. Now look at these two questions. The first one says solve without using tables log 62.5 base 5 minus log 1 over 2 base of 5. Then this question is to simplify, right? You have to simplify log 8 base 10 minus log 4 base 10, all divided by log 4 base 10 minus log 2 base 10. Kindly drop your solution to this question in the comment section. And don't forget to check out the part 1 and part 2 of this video while you share this video with your friends and loved ones. Till we meet again, bye for now.